Yeah, and some students at Quincy High School this morning, they've actually built their own robot.
Pretty cool. And I think it works really cool too. Lindsay Boach is out there to check it out and see what it does. Good morning, Lindsay.
Hey, good morning, guys. Yeah, I've seen it in action. It's actually really cool. I'm not going to show you exactly what it does just yet. I will give you a clue, though. Chad, I know you like buzzer beaters, and we are in a gym, so that's all I'm going to say for now. Right now, the teacher, engineering teacher here at Quincy High School, Christy McKenna, joins me. How did this whole program get started?
We started a program called Project Lead the Way last year, and I teach actually digital electronics, and then my counterpart, Caleb Smith, teaches Principles in Engineering and Introduction to Engineering Design. And it kind of fell into place. There was a grant available through JCPenney's, and they're sponsoring 900 teams this year for First Robotics. The entry fee for a rookie team is $6,500, so it's very expensive. And then other area community businesses have stepped up, as well as friends and family. Harris Corporation has been wonderful to us, providing engineering support. And this week, Titan Wheel got on board with a $2,500 donation. So also Knapheide Manufacturing, Western Illinois Veterinary Clinic, Motion Industries, and there's several other businesses, Strother Automotive. And so there's a lot of friends and family donations as well.
And what is FIRST?
FIRST was started by an engineer, Dean Kamen. He thought that our country and students in general were falling behind, and we needed a way to step up the STEM, science, technology, engineering, and math. And so they decided to drive it by building robots and creating a competition for students, and every year it is a different competition. And do you want me to reveal what it is or not?
Sure, if you want to.
This year's competition is Rebound Rumble.
Okay.
And so the 3-on-3 basketball competition between robots.
Oh, that's why it shoots basketballs. Yeah. Okay, I got it. And how did you put this team together?
It really fell together all on its own. The kids are very excited about building robots. They're here late on weekdays and weekends, and I have to kick them out.
All right, so we're going to show a little bit about how it works. Vin's going to talk about that. You have two controllers here. Yes. How did you guys, first of all, get started in planning for this robot?
Most of the ideas came from our engineering class. We started after school building robots. We have a VEX kit, and it's just a bunch of parts we can put together and build miniature, smaller robots, and they're remote controlled. And our drive system came from one of my ideas of actually having it run like a tank. So the left joystick runs the left wheels, and the right joystick runs the right wheels. So it gives us an easier way to actually turn, and I mean, we can actually turn on a dime, and we can go backwards, forwards, turn either way. Our joysticks, we also have all of our commands here. We can run the chute, so we can grab the balls, load it up, start the thrower. We still have a little more programming we'd like to put on there, but we can also control the speed that the shooter actually runs at. So if we're too far or too close, we can actually adjust, immediately. But everything is wireless, and the robot, you can see there's a white router on there, and that is our connection between the laptop and the robot, and it's pretty good. There's very little lag, if at all.
And now, how long have you guys been working on this?
Oh, over a month, several weeks. I mean, it kind of all zips by fast. I mean, I don't even pay attention to it. I kind of lose myself in it.
And we're going to show how it works here coming up in a little bit. We're going to use those two. I'm not going to touch it, but they're going to use the two joysticks and show you how it throws a basketball here coming up in the next half hour. Guys.
Very cool. I can't wait to see how it works.
I'm kind of surprised it was only a few weeks. I thought he was going to say 6 months or something.
Yeah, years. But yeah, it's a few weeks.
Yeah, nothing.
And yeah, and the competition is in late March, so they still have a little bit of time to tweak things if they need to.
Yeah, hopefully they don't have to, and they can just kind of relax for a little bit. On the wall this morning, our topic is, what would you invent if you could? I think I would invent a machine that would just take me here. That's St. Bart's, a live look this morning. A couple folks walking on the beach. What a beautiful, beautiful picture.
You know what
Not
I
gonna
would
get too
call
bad
your
here today,
invention? I would call it an airplane. It would be amazing.
Maybe I could make some money off of this. I don't know.
I don't know.
Some inventors in the
Throw it out
tri-states this morning. The Quincy Area Vocational Technical School Devils Robotics team has spent the past 6 weeks designing and building an original robot.
And they're actually going to wrap it up this week, and then next week send it to St. Louis for the first regional competition. Good morning, Lindsay.
Hey, good morning, guys. Chad, you might want to sell things called tickets. You might want to, you can maybe even make a lot of seats on this little invention that you have.
I know.
I should make
all
them very
coming
cramped
together.
and not offer any food.
Yeah,
No.
exactly. I'll
be
think of
awesome.
some more ideas for you here.
You keep doing that.
Yes, we're live this morning with the robotics team and their robot. There's a name for the robot now, right?
Yep, the Little Devil.
Okay, and Matt Pranger's joining me now. He is the team president. How did you guys create this robot?
Well, the base frame actually came with a set of instructions that we followed, and everything above, your base frame you see there was fabricated by us. All the lift kits, the actual chute that brings it up, and all the launching assembly was all custom fabricated by us.
How did you think of where to put what and how to get it to shoot? Is it just trial and error, or?
We had about 3 or 4 ideas that were bounced around. We probably changed designs a couple times and finally found something that worked, and we went with that.
And there's no wires attached to it, so how does everything
Well,
go?
The battery on the side over here that he's taking a shot of now, that's what powers everything on the whole robot. And also that white bridge, that essentially it's a router. It's on top there is actually what communicates wirelessly to the laptop here. That's how it's controlled.
And you guys had to make codes and things like that?
And the code's actually right here on the laptop.
And what is each, you have 2 joysticks here.
Yeah.
What do each of the joysticks do?
Well, the left joystick controls your left drive motors. So it's like driving a tank. You have forward, backwards, and then you go like that to turn.
Okay.
And then we have it set to where if you hold this down, if I were to enable it, it would actually spin the launching motors up, and then we hit this to advance. We hit this button to advance it into into the shooter.
Okay, and now Vin's going to drive it here, and we're going to test this out. I'm just so fascinated with this, and the last project that I remember making in science class was a catapult, and actually won first place, so how about that? Here we go. And there's a belt that brings the basketball up, and then it shoots, and look at that. How did you guys position it in the same, you have tape there. Is that the only spot that it can shoot from right now?
It can vary, but all we have to do is change the speed, which is right here on these is actually where we change the speed at for the launching motors, and we can change what amount of backspin it has, how much forward spin it has, and we can change all that. So.
Oh, and there it goes.
Yep.
Do you know how fast it goes?
It's pretty fast. I'd say a little over 15 miles an hour, wide open. Yeah.
And it can pick up balls also, which will be helpful in the 3-on-3 tournament.
Yeah.
Are you guys nervous, excited?
A little nervous because I'm not sure how it's gonna do on the whole competition. If something's gonna break, how are we gonna fix it? And just last minute unexpected events.
What was your favorite part about creating this robot?
I've always been an electronics and computer guy, so I enjoy doing all the electronics and getting everything wired up and programmed, and that's kind of my strong suit.
Awesome. Here it goes, shooting again. Oh, so close. Very, very cool stuff. We're going to talk to these guys a little bit more here coming up in the next half hour.
All right, Jeremy Lynn, look out.
Exactly.
All right, thanks, Lindsay. Special effects in movies are getting better and better as technology improves.
And some students at Quincy High School, they've built their own basketball playing robot. Good morning, Lindsay.
We've come a long way
Morning,
since Short
guys.
Circuit.
Yeah, I'm going back to high school. These students are way more advanced in technology than I could ever imagine being, because they have built this robot here, and it shoots a basketball, which is really, really neat. Vin joins me now. Explain each of the little parts of this, because there's a lot that goes into this robot.
Yes. Our main supply, power supply, is our 12-volt, 17.4 amp battery. That's a lot. That's enough to knock somebody down on the floor. And it goes through our breaker, and that lets us control the power to it. So if we need to shut down real quick, we just press the red button and it's dead. Okay. And then the power goes to our power distribution board. Here we have all the main electronics. We have the serial board, which we load all our commands from the laptop to there. And here we have all the breakers and each of the motor controllers, so that we can adjust the power to each motor, and we have 7 of them that control all our moving parts. And we also have a live feed webcam on top, so we can actually see where we're going or what we're looking at.
And that'll be helpful in the 3-on-3 tournament.
Yes, we can actually, right now we have it looking forward, but we can actually adjust it so we're looking up at the baskets, or if we need to really quickly, we can move it somewhere else.
And now these are the wheels that they kind of help to shoot the ball.
Yes, these will spin in opposite direction, and we have one of the motors here that control this axle, and it pushes the ball into the shooter, and from there the ball gets shot into the basket. And right behind it is our shoot mechanism, and it's controlled by one motor and a gearbox, and this belt runs up and down, and the ball will actually be caught on the bottom, and it will be directed upwards onto the actual shooting. And then right beneath the power distribution boards, you can see the two black motors that actually run the robot. And right here you can see that we have 4 out of our 6 wheels are actually powered by chain and sprocket. And on the front we have our arm that actually lowers the bridge. And at the competition there are 3 bridges, I believe, and we have to cross them to grab the ball, cross it again to shoot it in the baskets.
And there's a lot more involved than just the hard wiring of the robot. It all goes into a computer. And Matt joins me now. Explain a little bit about what all of this means.
Well, our code's developed in National Instruments LabVIEW is who makes the software. And this is our main code right here that tells the robot what to do. Up top here, this is what tells it how to launch the ball. And this code right here is telling it how to drive. And this line right here is actually telling us when to advance the belt, and it's basically saying when button 3 is pushed, which is this one right here, it'll advance that belt onwards. And just all those have their own little function that. Yeah.
And how did you figure? Because you've kind of figured out how to use this program.
Yeah, I self-taught myself kind of. You know, I had some YouTube videos I watched about it, and I just kind of played with it in trial and error, and I finally got it right.
And now competition is coming up at the end of March. What are you hoping for?
I just hope all of our code sticks together and everything runs as planned, and we don't have any last-minute unexpected errors.
Well, we wish the best of luck to you guys. We're going to keep in touch with you guys to see how you guys do when tournament time comes around, guys.
All right, very nice. Thank you, Lindsay.
Yeah, best of luck to all of them.